Hello everyone. Hey everyone. Yeah, yeah, yeah. So this is funny. So I was gonna do a thing with Libempics today, but I can't work on Libempics right now because I need some more information from the contributor of the PR, and that is gonna inform me on how I can test those new functions in those helium functions. And anyways, a good friend of mine that hangs out in one of the groups, or a couple of the groups that I'm in, under Alston. It's a really nice C developer, and also like how do I say it? Quite a strong networking mind. I think he's done quite a lot of the networks that exist in Africa and stuff. So he's a really good networking developer. Anyways, Andrew made a linked list application the other day, and I kind of want to try and explore it. I haven't used it before. I haven't used it before. And also, this is the other thing. I don't know that I'm that good at linked lists or data structures in general. I don't understand them that well. I understand the one I'm using very well, but then once I finish using it and I want to use another one, I'll have to go read up on it and understand it and kind of like try and remember stuff. So it's been a while since I've had to like look at an implementation of a linked list or actually use a linked list. So let's actually see let's see what this gives us and kind of like try and sort of explore what will happen, how this code works, okay? And then we can go from there, I think. So I'm gonna just quickly download this code. Let's put it in our yeah, I had it here. I'm gonna quickly download it, and then we can start exploring it. CD link lists. I think that's it, and then yeah, let's actually just jump into this. And what is it? Yeah, there's another folder there. But let's see this. Just some junk code that I wrote to demonstrate linked lists and hash maps, etc. This contains a copy of XX hash, which I used for hashing for the hash map routines. Copyright on that is retained in its respective files. Okay, cool. So the first thing we need to do is just follow what this guy is teaching us here. So what is XX hash? That's what I don't know. What is XX hash? Ooh, let's see. XX hash is an extremely fast non-cryptographic hash algorithm. Working at RAM limit speed, it is proposed in 4 flavors: XX H32, XX H64, H364, H3128. The latest variant, XX H3, offers improved performance across the board, especially on small data. So there's a couple of ports to this library, it seems like. It's a non-cryptographic hashing algorithm. So basically what it does is it computes a hash that has not been run through a cryptographic engine. So basically this is not suitable for cryptographic stuff. How am I dealing with this? Am I not oh yeah. It's funny because I actually currently have an MCU boot error, and my MCU boot error is all about like random number generations because the custom SoC that I'm working on doesn't have has a random number generator, but it's not implemented fully yet, and thus my MCU boot thing is not working. So it's so insane that I just decided to explore this, and I found out this is insane. Okay, so cool. So XX hash is it's just a hashing algorithm. Yeah, yeah. So how does that work? Can we go to GitHub and see it? Or where can I see it? I want to see XX GitHub. So how does XX hash work? You give it something and it hashes it for you. Uh, um, I've read that. What? How does it work? Yeah, this is some test. I don't care about that right now. Maybe later. How does it work? Does anyone know how it works? Chat. Does anyone know how this works? No. Cool. So there's an example over here. That's cool. Let's look at this example. The simplest example calls XX hash 64-bit variant as a one-shot function. I wonder if XX hash is a thing on my XX hash. No, that's what I was wondering. Is it a thing? So the simplest example calls XX hash 64-bit variance as a one-shot function, generating a hash value from a single buffer invoked from a C or C++ program. It's actually quite easy. Let's actually see if we can explore some stuff in here. See the linked list app and then ls and then nvim. Let's look in here. Wait, do I have an nvim going on? Let's look in here. Let's look at, say, something like main.c. Include XX hash. I see you're not including it here, so you're including it somewhere else. Let's actually do a quick, let's make something here. Main.c. And then I want to do something like actually no. Yeah, I want to, no, unless, that's fine. CD link list up, ls, and vim in here. Let's just rename this main function so that we can come back to this later. Mainy, and then main, and then let's do a touch main.c, and then let's get in there and just do some stuff. Let's get in here and just do some stuff. Let's get in here, and then what I want to do is I want to implement this hash include what do we want to do? I think it's XX hash. Yeah, is that R? Yeah, XX hash dot h. No, it can't find that. XX hash forward XX hash dot h. Yeah, that's fine. And then I'll probably want to do stdio. Yeah. Include stdio. .h. No, isn't that why? Why can't I do that? Chat. Why can't I do that? Why can't I do include std dot. Yeah, let's do that. And then let's do before we even try anything, let's do int main, and then in our main let's do something like printf, something like I am working. And let's see. So if we do ls, yeah, gcc main dot c. What happened there? Yeah, out. Yeah, it works. Okay, cool. So now let's use XS hash and see how that works. So I need to give it some sort of buffer. Let's make a silly buffer. Let's make a silly buffer, and we can do something like a buffer. Let's make a buffer full of zeros and ones. Int. Let's go int my buffer. My buffer, something like 5, something like that, 5 or something, and then we can go 1, 2, 3, 4, 5, something like that. I think that's a buffer. That's a valid buffer. And then in here, let's do something like give me a hash of this thing. Some seed. Int seed equals something like 3479. I hope it just wants something of the sort. That's a good seed. There's a seed we need, and then let's hash this out. So let's make a xx hash xxh. Is it a xxh64 hash? Yeah. And then this is we're gonna call this a hash, and then this is gonna look like so let's do xxh64, and this is actually a function. That was a 5, 4. That should work. And then I should do my buffer, and then I should do 5, and then I should do seed. Does it want addresses or just that? So just password value. Okay. My buffer. And what is a hash? How do I see the hash? How do I see my hash value? Can I convert a hash into a string? Does anyone know? Hey, Saksham, how are you? I'm not really teaching today. I'm trying to just explore hashing, a linked list implementation that has a hash function in it, and I'm trying to learn myself. And I'm not really sure. I think what I'm teaching is how to explore development and find stuff. By the way, for those people joining us, there's a community link in the. Wait. I need to add a community link to the description, and then in the community we talk about all the stuff we do a lot more. Invite people, edit, no limit, never. I was gonna be working on libmpix today, but then I just got the information I needed now, so I wasn't very ready for libmpix. If you're on, in the description of the video, there's a link to the to our community where we discuss all the stuff that we're working on and such. So how do I print this hash? Can I print it? Can I print it somehow? XX hash. How did we end up exploring XX hash? We are now exploring XX hash rather than doing libempix, which is fine. Cool, but how do I print something of sort? I don't want to do GDB to explore it. Oh, that's used quite a lot of places. That's cool. It's very cool. Yeah. So today we're just exploring a linked list implementation. That's what we're doing. But before that, we want to see what's happening. Yeah. Is it not possible to ever see this hash? Is it possible to see this hash? I'm okay. Yeah, this is fine, but is it possible to see this hash that's been generated? That's what I'm really wondering. Can I see the hash? Can I print it out at least? Is it some sort of string? Is it what is it? What is a hash? Do I have to go find out what a hash is? Brian, who's here? Who's here who can tell me what a hash is? Like what data structure is it so that I can get to print it? 64-bit hashes. I kind of want to know what this is. XXH64. This type. That's what I want to know. What is this type? Is it like a string of numbers or something? UN64. UN64. So it's a 64-bit. If it's a 64-bit integer, print 64-bit integer. Let's see. LLD. But will LLD actually? I can use LLD. This is fine. Let's try it. Let's use LLD. But that would give me just one. I want to see the whole. Here is the hash. I know this is somewhere in here. I would like to see this hash. Let's see. That should actually make it work. So GCC main. That's no. I just added LU. Please. Let's run it. GCC main. Yeah, undefined reference to XXH64. That's how it says how to use this thing, at least. It's actually quite a. It looks like it's even more. It's even more even more complicated than uh, just a 64-bit integer, because it looks like it has some state. It looks like it's a whole struct in itself. XXH64. That should just work. XXH. Yeah, that should just work. Anyways, let's abandon this. We'll see it later. Main. Let's actually just explore Andrew's code. In here, this needs to be main. I know XX hash is used somewhere else, and then this here I need to move mainie to main.c, and let's see, unless there's no build script in here, so I probably just need to build all the so gcc something like main.c list.c. I think that's all of it, and then I want to build this into linked list. I need to specify an output linked list. Hash entry hard data, expect value. Cannot find linked list. Where is this? Okay, cool. Here's the problem. It's here, list.c. Alas. Yeah. Let's leave the warnings. Linked list. Okay, cool. Let's see what it does. Actually does. Let's see it actually does. So what does this do? Locking enable, taking lock, unlocking, completed list of build 20 with 20 entries, taking lock, unlocking, completed list field, taking lock. So we're doing something with mutual exclusion somehow. So we're taking the lock, and then we're putting all this stuff, and then we dump the things, then we unlock, and then we take the lock, and then we unlock. Unlocking, lock, unlocking, lock again, so that you can do this, and then that, and then that. Do I have to read the code to see what this does? What does this expose? Where are we? Yeah. This is the builder, this is the runner. We use this, I like the runner to be on this side. And then in here, let's actually just open the code. And then perhaps let's go like, what is our linked list? Can I get a written thing here? Let's go. So, a linked list is a linear collection of data elements whose order is not given by their physical placement in memory. Okay. Instead, each element points to the next. Okay, cool. So, it's not a contiguous arrangement in memory. It's just that each element has a source. Sometimes it doesn't have. If it doesn't have a source, it's gonna be the root, I think. But then the next element is a pointer. So you have a pointer. You have an element. Excalidro. So basically what we have here is delete. Anyways, let's do that. Let's make a thing here. Okay. So what you have is every element is like the element as this as such, and then you have the element in here, and then you'll have a pointer to the next item, and then in the next item, this is a pointer, this is an address, and it points to some item, and then this item is going to have something like the element, and then another pointer here, and then this is going to have another element, and then this. So each item is an element and a pointer. Okay, and so on and so on and so forth and such. So this is that's basically what is happening. However, okay, let's see. That's the description. Each other. So they don't have to be like a normal array. You'll get like a memory batch like this. Okay, in a normal array, you'll get a memory batch like this, and then if it's a string, you'll have like a termination at the end. So you have like all these elements in the array or in the list, whatever one I'm doing, right? And then this list will be like, the next one is just like, if these are all like 32 into 32, it's 4 bytes, and then 4 bytes, and then 4 bytes, and then 4 bytes, and then 4 bytes. If these are like int 32, it's 32T. If these are 32Ts, so you have like 4 bytes, 4 bytes, 4 bytes. So the way you traverse this list, that by going by like from one and then from here to that to that to that, the way you traverse this list is you have some sort of you have like some sort of pointer, and then every time you want to do the next one, you add pointer plus, like here you would say 4 bytes. But usually rather than say 4 bytes, you would add it, you would increment some sort of data structure by itself. So you take like a 32-bit, 32T, and then you would do equals 32T plus plus. So that way it increments itself. So this is all like this is all how kind of how it works. Okay, cool. Why were we exploring that? Because we wanted to know what linked lists were. And why does this linked list need a hash? Control hash. I see why. So what they're trying to implement here something is a linked list that has a write and read or find. Is it read or find? It's something like it has a constant access. You can basically go and find. It would take you the same amount of time to add an element to any position in the list. The reason it would take you the same amount of time is because, and that's why we're seeing a hashing thing here. Hashes should be unique. So whenever you want to enter an item, you would use the hash of the item to find it. Basically, every time you enter an item, you hash it before you enter it. You hash it before you add it. I don't know. I don't know. I genuinely don't know. I'm just conjecturing in my head. So they allocate some space, if not new. How do we know it's new? How do you know it's not new? How do we know it's not new? I think there's some hashing they do every time they... Okay. I think there's some hashing they do and then from there on, every item that is added, you compute a hash and you add it. So fine, you already have a list of all the addresses that you want to access, basically. I think. I don't know. I genuinely don't know. Let's jump through this code. Yeah, main linked list up by Andrew Alston. As you see, yeah, that's Andrew's code for sure. Use locking. I don't know why you're locking. This is probably because you're trying to run some stuff in parallel. I don't know. List set from array. Okay. List set from array. List set from array creates a linked list from an array. This does not copy data from the array. It merely points to the array entries. So I see. So there's some sort of zero copy mechanism that's trying to be done here, or that's being done here, where the data is actually rather than copying the data into a buffer and then using that buffer to make a list, the linked list, in essence. So as you remember when we just drew a linked list here, let's actually go fine. I'm just trying to understand here. When we just draw a linked list here, so right now, no, give me a pencil. So right now, so there's an array here. There's a source array. And this array has elements in it. Okay, E. So the way this function is described is if you pass that array into here, this does not copy data from the array. It merely points to the data. So we make another linked list here. Actually, I don't want to make it like that. So we make a linked list down here. Okay, we make a linked list down here, and this linked list is just filled with addresses. Instead of having an element down here, we have a pointer to that, and the next one points to that. Okay, and then this one is this one, so it points to that, and the next one points to that, and then this one here is this one, so it points to that, and then the next one here points to that, and then the next one here points to that. See? So the new linked list is made up entirely of addresses. This is kind of cool because it's a little cheaper, I guess. It's a little cheaper because number one, you don't copy the data, so you only have one canonical copy of data, and what? You have one canonical copy of data, and you only maintain addresses to the data. It's already cheap. It's already cheaper than copying the stuff and hashing it. But so, where's the hash involved? Why are we using hashing? So this is add head data is prepend, and I think add last data is append. Add set data is append, like kind of like to the tail and to the head. I kind of want to see where this thing is defined. Actually, no. It's this. Yeah, let's see where this is defined. Where am I? In list.h. That's fine. Structure. Linked list contains contains the list as well as the tracking pointers of the head. Let's actually improve this. Let's write some docs here. It's bullshit. It's bullshit. It's bullshit. Let's write some documentation because this guy doesn't want to write. He says he wrote it for the lulz. That's cool. It's fine. It's cool. It's cool. We're still gonna. Struct list contains the list as well as tracking pointers for the head and the tail of the list. So you have a list. You have some sort of as we've discovered here. Yeah. Anyways, let's use the Wikipedia one. You have a linked list like this. Okay, this is a circular one which we'll encounter just now. But you have a linked list. This I don't want a doubly linked list. So this is kind of the head of the list, and this is the tail of the list. The last element and the first element. And you have pointers in this code. So you have a pointer here, list. List refers to the whole thing. So it will point to this beginning part, and then there will be some termination thing that tells us maybe the tail is a termination condition. There'll be there's some data here that tells us this is the end of the list. And then head is going to point to this 12 element, and then tail is going to point to this last element over here. And if it is ring, then Andrew implements this part. Then Andrew implements a circular linked list where the last element actually circles back and points to the first element. That's cool. That's cool. That's chill. That's chill. So this is a set. This is. Anyways, you see, you don't need documentation if you read the source. Oh my god, I'm just gonna get flagged for that. This is set if we're using locking, though not technically necessary. If it's not technically necessary, Zach will not pay attention to it. Any questions so far? Any questions so far? Any questions so far? So if we're using a lock, then locks are gonna be involved. I'm kind of not gonna look at this. I really want to see where the hashing function is applied. And even where the collision is used. Because there's gonna be like collision detection and stuff. I hate that. These functions should be documented. Someone should tell us what these functions do, because I want to find the function that why do you have XX hash everywhere if you're not going to use it, Andrew? Andrew! Ah yeah, it's here. You're using it. Cool. Why do you have XX hash if you're not going to use it? You are using it anyways. Let's remove that. Why? It's confusing me. I don't want to see it now. So, let's see. Linked list new makes a new struct of linked list. It returns a linked list. It makes a new list by allocating a list, allocating to the size of list. And then if it's not new, it returns null. That's fine. We should probably printf there and say we could not allocate, but that's fine. And then it sets the data to data, and then it says the data size to data size. I want to see what this... We've probably done this, but I want to go see what it does. new. Wait. Control. Wait. So yeah, data and data size. Yeah. So what is data? Data in linked list. Okay. Data size of data in linked list. Struct ll list. Next entry in the linked list. Previous entry in the linked list. So you're holding two addresses. You're holding 2 pointers, to the forward and to the back. Creates a new linked list entry, not a new linked list. So cool. We found it. So this adds an element into the linked list. Yeah. Okay, cool. Fine. That's what it does. And then this creates a new linked list container. Do you want to go see what this is? Because I see some hash maps being used here. And I see some locks. But if I do not define a lock, so I can ignore the lock. So I will ignore the lock for now, which is fine. That makes it easier for me to understand. So let's actually read through this. So create container new creates container new is a pointer to a function. So it's going to be called like something like, at some point there's a struct that contains this container new. You're going to make some struct somewhere that contains that container new, isn't it? There's a function that is doing there's going to be some silly thing. Look, even this is a pointer to a function. Container new list. Yeah. List containers, right? Yeah. Container new list 20. Why is this a pointer to this thing? Why is this a pointer to this thing? And why? Well, how are you gonna use it later? Why is it an address of this function? Is it because you don't? My keyboard stuck. Yeah, we're back to the same place. Anyways, contains a new list. Contain a new list creates a container with a doubly linked list containing list entries in the list. Containing list entries in the list. So a list entry is an entry. Okay, cool. So that makes a doubly linked list. Okay, cool. We're sort of kind of finding it. Yeah. So this doubly linked means instead of just doing the tradition, well, I don't know if it's traditional, instead of just going like linking to the next item, you link to the next item and you link to the previous item. So you basically have a sort of like a next and a previous. I'm actually sorry for this. My hay fever seems to be flaring up again. Anyways, any questions so far? Anyone want to make fun of me or something? That's cool. Show me how I don't know. Let's see. Node. We're just constructing it. It's not not interesting or interesting. creates a container new list, creates a container with a doubly linked list, okay, containing list entries in the list entries, list entries. So there's something here, it's called list entries. Entry. No. Okay. Okay, anyways, let's just keep going. Where am I? No, I don't want to be here. So, do I really want to be here? Yeah, let's just. Can we see this from top to bottom? So that's good. And I'm going to remove this because I don't like it. It's not being used, so it doesn't tell me anything. I'm not using a lock for now. That's fine. Okay. So, unit 64, test 20. There's an array of size 20. And then we fill it with randoms. And then we make a struct list container. Let's look at this first of all. So we make a struct list container. It contains that. So we just make a struct for now. Okay, cool. And then we do a list set from array. We give it a container. Container.list. Wait, before we go on, container.list is equals to container.head. Container.list pointer that yes, that is correct. That is supposed to be that way. Yes, because when you're doing addressing of stuff, like if you're dealing with a string, you point to a string by pointing to the start of the string, and then at the end there's some sort of terminator. So if someone wants to use the string, they take a pointer to the beginning of the string, and then they go until they find a terminator. And when they find a terminator, then they know they've gotten to the end of the list. Yeah, that's fine. Okay, that's fine. So yes, container list points to the head of the list. That's fine. It won't fail later. Will it fail later? I don't think it will fail later. I think people actually do know this, so that's cool. So, okay, cool. It sets the list and the head to be the same, so the same pointer. Okay, fine. And then it says list set from array. List set from array. Why is there a set in this? Are you gonna do some deduplication? What if I do this, Andrew? What if I do test 1 is equals to 1 or something like that? What happens if I do that, Andrew? What happens if I do that? So let's just make the program again. And then learn linked list. They're all the same. Contain 1. I don't think you do deduplication. So does this actually do collision detection then? What are you doing, Andrew? I don't know if Andrew's here, but was Andrew actually implementing collision detection here? Or collision avoidance? That's kind of how you should say it. So list set from array. It's not a set. List set from array. List set from array creates a linked list from an array. This does not copy the data from the array. It merely points to the array entries. Cool. List set from array. What do you say? You take the container, that's fine. You take a pointer to the head, okay. You take a pointer to you take the size, and then you take the size of entries, and then if not count, what is count? Okay, cool. So if the pointer, if it didn't allocate enough space, that's fine. Okay, cool. Uh, Lock. I don't understand why you're locking, but that's fine. Uh, okay, cool. That's okay. If count dot list entries equals to less than number of entries. Okay. If the list entries, what is a list entry? What is a list entry in listed entries? This is just a size, just a size, just a size. If it's less than, if that is less than, if count at list entries is less than number of entries, that's fine. Okay. If count is ring, okay, one entry array entries exceed ring entries. Tell me about this. Why am I confused? Why am I confused here? So here, so 20. Let's make it break. Let's make it break so that we know what happens. Okay, cool. Just go out and do stuff, man. Just go out and do stuff. Just doing stuff. We broke it. We made it die. We got a seg fault. We got a seg fault. Why did we get a seg fault? Does it say locking enabled? Locking is enabled. Yeah, so why do we get a seg fault? It shouldn't seg fault. It shouldn't seg fault. It should not seg fault. It should not seg fault. Should it? Should it? Oh, and is ring. Okay, and is ring, and is ring, and is ring, and is ring. Fair enough, fair enough, fair enough, fair enough. Fair enough. It has to be a ring as well. Where do I set it as ring? It is. That's for later. That's for later. Cool. So let's just keep going. So okay, cool. Lock container. I don't know what lock does. I'm unwilling to find that right now. Define use lock if def use lock. Okay. Lock container. I don't want to figure out what a macro is doing right now. It's not what I want to do right now, so it's fine. I'll just assume lock does some sort of mutex, some sort of mutual. Just go find out. While atomic load. What is atomic load? See atomic load. I know what the statement means, but I don't know what it means in C. Atomic. That's worse. That's worse. That's the wrong direction. Atomically loads the current and returns the current value of the atomic variable pointed by object. The operation is atomic. It's an atomic read operation. An atomic operation is one that you do in one set. Like you do it from beginning to end without interruption. That's what an atomic operation is. Atomically loading is just loading it all from beginning to end without interruption. That's probably why we're seeing a lock on the other side. The lock is there to make sure you never get interrupted or something of the sort. So atomic load container.locked. What is container.locked? Control O. Go back. Let's go back and find out what locked is. Locked. There's a lock there. Atomic load container locked. Did you guys just see that? I jumped. I jumped back to main to jump to the function to jump to the struct because you remember I did that and I went to main and then I went to that, which shook me back to the. It's fine. I was here. I was just down here. So yeah, just the next time you're confused, remember to look up. Remember to look up. So there's some sort of lock in here. And this lock is what is atomic loading? It to me, I'm not even looking at it. It sounds to me like atomic loading is loading at once, that without interruption. That's what it really sounds to me. Mm. Yeah, let's look at it. This person is asking like what is atomic load. They were just using assignment, which is the same thing I expected. Like it's just an assignment, yeah, but not really. No. Okay, foo dot equals atomic load, atomic variable is a shortcut for foo equals atomic load. Let me just sorry. I learned this from the sorting live stream. You shouldn't have the text too small so people don't see what you're doing. It needs to be seen. So basically, this whole thing is a shortcut for using atomic load explicit, which that has a use case when you want to use an ordering weaker than the default. And I remember orderings. I remember orderings from school, but it has been a long, long time since school. And I think weaker, weaker ordering. My life is always about just going from paper to paper to paper to definition, and then I do this thing where I have to go find out where I am. Like I'm lost, but I'm where I'm supposed to be, but I don't know where I am. So I have to like just go jump out through so many documents and find out what I need to know that I probably already know. It's just in mathematics, or rather, that's a good image. It is. So in mathematics, order theory, weak ordering is a mathematical formalization of the intuitive notion of a ranking of a set, some of whose members may be tied with each other. So it's just 1, 2, 3, 4, 5, 6. It's list to most. So what is a weaker order versus a strong order? Sorry, I keep keeping quiet. two elements x and y of s or of a set S are said to be incompatible with respect to less than if neither x is less than y or nor if neither x is less than y nor y is less than x is true. So these are things that cannot be compared size-wise. I get it. I know this. I don't remember where I dealt with this, but it was doing some sort of stuff with Elixir, and it's been maybe like 5 or 6 years. I don't remember, but this is to do with complete orders and partial orders, or was it something to do with GraphQL or something? I think GraphQL and GraphCool. You're supposed to say GraphCool. GraphCool and something like n+1 fetches, and there was some sort of thing there today. Yeah, that had that, if I remember. Yeah, that's when I dealt with like partial ordering and complete orderings, and it was some sort of. This is very important when you're doing orderings, like order by biggest or smallest or something, and then you have to be aware of these things, because sometimes you have a UUID and an integer, and those two cannot be compared, and if they cannot be compared, then you can't come up with an order between them. Okay, cool. So that's fine. I'm bad at math. I'm sorry. I'm bad at math. Sorry about that. I didn't even decide what that means. I kind of surmised. We were looking for what was the meaning of atomic load. So weak ordering is when the thing can't be stuff. So, and the main reason for using atomically load explicitly in our source code is probably to remind human readers that a variable or a pointer is atomic. Or maybe as a part of a macro, using atomic load macro input would create a compile time error for a non-atomic pointer, which is exactly what Andrew is doing. No. I found it. It always just finds itself. Andrew is using atomic load inside a macro to do this container locked, and this tells us that the main reason for using atomic load as a part of a macro would create a compile time error for a non-atomic pointer. What is a non-atomic pointer? I don't know. It doesn't sound like a pointer could be non-atomic, because that would mean a pointer with spaces in it. When you're doing contiguous and non-contiguous spaces. Non-atomic pointer. This is what happens when you read code that has been written by people with like 40 years or 30 years of experience, because like all of this stuff is available to me. This is just normal C. This is just all normal C. I should know this, but I have not written enough code to like explore this. I have not had enough problems in my life to find this as a problem. And anyways, Andrew's done. Andrew spent most of his time. Andrew's like an IETF member for networking. So he works for the foundation that makes the rules. What do you say? Let's read about atomic point. 10 years, 10 months ago, someone asked this question. So my question involves STD atomic and the data it dispoints to. If this, for someone who hates C++, Andrew, you write an awful amount of C++. You just hide behind the C. If you're using foreign function into FFI and you're just calling it to C++, it's writing C. It's just mnemonics for C. I don't know, for C++. Anyways. progress C++ atomics. I don't really want to learn C++ right now, but I do want to know what atomics are. Can someone please tell me what an atomic pointer is? Which is went straight into what is an atomic pointer? I don't care right now. I don't even care what language I learned it in, but just tell me what an atomic pointer is. Yeah, exactly. This is exactly what I was looking for. So, no thanks. Yeah, that's the person already. Check. That's the person who wrote this article, and they're available for hire as a full stack developer. Check them out. That's their Gmail. Send them an email. Okay, cool. Atomic in computer programming refers to the performing operations at one time. This is exactly what I said before. You need to. It all goes in one. It all goes in one step. It can't be interrupted. So, atomic is basically a critical section in embedded where you want to do something without you do this thing where you disallow. Do I have some code that does critical sections? Basically, you disable interrupts, you do the work you need to do, and then you enable interrupts back. That's implementing an anatomic operation. It's a critical section. It's like you use a mutex so that no one can mutual exclusion. You are allowed to use that process. You use that process, you finish, and then you go back. Uh, Atomic in computer programming refers to performing operations one at a time. Objective C has atomic properties. It ensures safe read and writes to property in from different threads. Okay, cool. So the atomic pointer is a generic type. Unlike value, does not require asserting that your stored value to access it. No one is telling me what an atomic pointer is. What in the world is an atomic pointer? Chat. Does anyone know what an atomic pointer is? Leave it in the chat so that I can find out. Make fun of me and point. They say, that guy over there does not know what an atomic pointer is. You're wrong. Okay, cool. Fine. Thank you. Atomic types. Explanation. Objects of atomic types are the only objects that are free from data races. That is, they may be modified by two threads concurrently or modified by one thread and read by another. What? So it's just a thing that you can modify from many threads safely. And a non-atomic pointer is a thing that you can't modify from many threads. So what Andrew is intending here is that if you point to, if the lock is something that is not atomic, then you will get a compile error. So basically, if I do this, I should get a compile error because that is not an atomic thing. Yeah, I just feel like I already removed something and I am gonna, it doesn't really matter. Shut. I'm not seeing any atomic problems here. Linked list. Well, this code is kind of bulletproof. That's given that. We give it that. Even if you make the thing non-atomic, it doesn't. Is it because I have to define use lock? But define use lock is defined. Define use lock is defined. Anyways, that's been a good session. It's been a good hour of exploring. I'm not gonna like jump around this so much. This is cool. That was a good session of reading this code and checking it out. Thank you so much for coming out and hanging out on one of my learning sessions. We learned a lot, I think. I'm suddenly now quite interested in this code. I would like to put it in a place where I can see it being used. I'd like to find a use case of it rather than just like printing things out and seeing them. But it is a linked list implementation, that it is for sure. What I don't know is if it has collision avoidance. So collision avoidance in linked lists is something like collision avoidance. So what we're aiming to do is to use some sort of hash map, a hash table to make it like you can't, to make it so that you can't, when you find a thing when you find a thing that exists, so you want to add something to the list and it already exists, you should be able to avoid that collision. And you use a hash, because if you hash a buffer or if you hash some data, it will always give you the same hash. So the thing is, you make a hash of the data that you need to enter into the list, and then when you go to enter it, if you find an entry there, it means you have another one, and then maybe you say you have two of them or something later. That's why I like to find a use case and then come and build on top of the use case. So we'll go and find a use case. This was just an impromptu one. It was quite cool, and I've had a lot of fun. Yeah, so thank you so much for joining me today. All 42 or 43 of you that showed up, that was amazing. We didn't get... are there any questions? Are there any questions so far? Even like, what's the point of this? Well, are there any questions? There's a few people around. Are there any questions? No questions today. So, thank you so much for showing up today. That was amazing. We did a stream, as always as promised. We learned some stuff. We Googled some stuff. We went over through the internet, and everything looks good. Shit. People know who I am on LinkedIn now. I mean on Reddit now. Anyways, cheers. See you all. We'll do another stream later.